Okay, so this next question is a probability question. Okay, asks us to work out the probability that she takes exactly £2.50. Now, there's a lot of information here that we need to really break down. Okay? Now, she takes 3 coins from the bag. Okay, 3 coins from the bag. So what we are going to do when we have 3 instances is we need to have... Oh, let me just check. A probability tree with 3 instances. Okay. Now, we need to have, in each instance, we need to have the probability that's going to be on the branch. Okay, so this is £1, £1, £1, and this will be 50p, 50p. So each time there's the option of £1 and 50p. So that's what happens each time. On these branches, I want to put the probability of taking £1. There are 3 £1 and 10 coins in a bag, and so my probability is 3 out of 10. That means my probability here is 7 out of 10. 7 50p pieces. Now, here, my total will be out of 9. Importantly, because I will have taken 1 coin already. In this instance, I've taken £1 already, and so I'm going to have only 2 £1 coins left. So I'm going to be left with 7 out of 9 here. Now this will be out of 9, and this will be out of 9. 50p has been taken here, and so I still have 3 £1 left. And here I'll have 6 50 pences left, because I've taken a 50p already. Now, because I've now taken 2 coins, each of these probabilities will be out of 8. So, here I've taken 2 £1 coins, so I only have 1 £1 coin left, and I will have 7 50 pences left. I've taken 1 £1 and 1 50p, so I'm going to have 6 £1 left, and 2 other way around, 2 £1 and 6 50p. Here I've taken 1 50p and 1 £1, so again I'm going to have 2 and 6. Here I've taken 2 50p, so I'm still going to have all 3 £1, but only 5 50p. This is all of my probabilities of each individual time I'm taking this. Okay, so up here is this is the first time, this is the second, and this is the third time I take the coin. I want to work out the probability that I take exactly £2.50. So I need to think of how can I have £2.50. Now, the only way I can get £2.50 is by taking £1, £1, and then 50p. Okay, I can't get it if I take £1 and 2 50p. I can't get it if I take 3 50p. So I need to find all the ways that I can do that. So it's £1, £1, 50p. It's £1, 50p, £1, and it's 50p, £1, £1. None of the others will add up to £2.50. So what does that mean? I need to multiply along to get my probabilities that I can put here. 3 over 10 times 2 over 9 times 7 over 8. I always multiply across a probability tree. So 3 over 10 times 2 over 9 times 7 over 8. So this one is 7. Just going to put this in a different number. See, in yours, hopefully your diagram is nice and big. This will be 7 out of 120. Okay. I will then do 3 over 10 times 7 over 9 times 2 over 8, and this will be 7 over 120. Down here as well, I've got 7 over 10, 3 over 9, and 2 over 8. And this again will be 7 over 120. So what I have is 7 over 120 plus 7 over 120 plus 7 over 120, which is 21 over 120, which will simplify down if I divide top and bottom by 3 to 7 over 40. And that's my answer. Okay, 7 over 40. Quite a complicated tree diagrams question, but hopefully you followed along now. Let's have a look at question 8. So this is now a bearings question, slightly different to the one you've done so far this week, and it's here as really as a challenge. But it tells us that the bearing of a ship from a lighthouse is 50 degrees. Now we know bearings are measured from north. They go clockwise, and they're written in 3 digits. So that's just 50 degrees. So if I've got a ship, and I'm hoping you've drawn a diagram to try and understand it, and I have a north line, it's telling me that the bearing, key thing that I've forgotten here that I should do, from a lighthouse, that tells me that I'm at the lighthouse. Okay, I'm at the lighthouse because I'm measuring from the lighthouse. Now it means that 50 degrees clockwise, okay, gets me to the ship. And I'm going to write that as S. Now, it now says to work out the bearing of the lighthouse from the ship. So, using the method we tried earlier this week, I'm going to say, right, that's S. And so the angle I want to measure is this one, because I know it has to go clockwise. So let's think, what do I need to find? And it's this angle here. I'm going to call that angle X. Here's where I know that 50 degrees plus X needs to equal 180 degrees. And so X, and that's because of co-interior angles, equals 130 degrees. 360 minus X equals the bearing. Call that Y if I want to. And so that 360 minus 130, which is 230 degrees, is my bearing and is my answer. The diagram there is the most important thing. If you got a diagram right, you'll get the question right. So let's move on to question 9. So I'm told the angle ABC and the angle BAC are equal. This is the angle ABC, this is the angle BAC. ABC, BCA. Okay. Those two angles are equal. So straight away I should know that this is isosceles. Okay. Now, what do I know about an isosceles triangle? That these two lengths also have to be equal. And if they're equal, I can write this. Okay, I can write this. Now I've got an equation there, and I can then solve that to find X. And I can do this even without looking at what the question is. Okay, I've got this information, I can do it. Now, I'm going to add X to both sides. And I do that because I always want all of my X's on one side of my equation. And I'm going to move this because it's smaller, lower in the number line than this side. That becomes 4x minus 5 is 19. Now, because I want the numbers on the other side, I'm going to add 5 to both sides. So 4x equals 24. can't do addition anymore. And so I just have to divide by 4. I get x is equal to 6. And that's in centimetres. Now I'm going to have a look, and I'm going to have a look at what the question says. It says work out the perimeter of the triangle. Now the perimeter is add up the sides, which is 2x plus 3x minus 5 plus 19 minus x. Now, x is 6, so I need to substitute it in for every time it says x. 2 lots of 6 plus 3 lots of 6 minus 5 plus 19 minus 6. I'm just going to do every single step here. 2 lots of 6 is 12 plus 18 minus 5 plus 19 minus 6, and I can start doing this. 12 plus 18 is 30, minus 5 is 25, plus 19 is 44, minus 6 is 38 centimetres. I think. I might have done that wrong. No, 38. Okay, 38 centimetres. Now, let's have a look lastly at question 10. So, some key terms to pull out here. Regular pentagon, okay, and it mentions angles. Now, I've got a regular pentagon that's talking about angles. The first thing I'm going to think is interior and exterior angles. Okay. And even before I try and think about which question they're asking me, I'm just going to start filling in every angle I can. Okay, every angle I can. A regular pentagon, I know that the internal angles, the internal or interior of a pentagon is n minus 2 times by 180. And this is the sum of where n is 5. 1, 2, 3, 4, 5. So that's 3 times 180, which is 360 plus 180, 540 degrees. Okay, 540 degrees. So one angle is 540 divided by 5. Which is 108 degrees. So on here I can mark this is 108, this is 108, this is 108, this is 108, this is 108. Okay? Now, let's think about how the next logical step is to try and find one of these. Okay? And we should see that they're both going to be the same, and how I'm going to do that is I'm going to go, right, if each of those is 108, I can do 180 degrees minus 108 degrees. I get 72 degrees, and that's that red angle. And if I want to, I can say angles on a straight line sum to 180 degrees. Okay, 180 degrees. So if I've got on here, I've got 72 degrees and 72 degrees, then it should be really easy for me to find this angle here, which is my last one. Call that x. That gives me 72 plus 72, which is 144, which is 180 minus 144, and I get 36 degrees.